Hey guys, Mr. Hallman here, and we're back for week 2 of our distance learning here, and we're going to be continuing our discussion of polynomials that we started last week. Last week we talked about classifying polynomials and adding and subtracting. This week we're going to talk about multiplying, and I've changed the video format a little bit here. So what I did was I already recorded this, and I'm going to narrate over it so you have an idea of what's going on. Hopefully cut down on some of the wobbling in the video down there in the bottom right hand corner from the webcam. So let's take a look at multiplying polynomials. And at first glance, it might seem like it's something totally new to us, but really we have already done some multiplication with polynomials. So these first three examples here, 1, 2, and 3, these are all examples of multiplying monomials by monomials. And we talked about these earlier in the year when we looked at combining like terms and distributing. We talked about this kind of idea in the exponents unit that we just went over. So let's take a look at these first three. Actually, if you want to try them on your own, you can pause the video, go ahead and try 1, 2, and 3 right now if you want. And then once you have them, start it back up. All right, so let's take a look here. When we multiplied the monomials, remember, we're going to multiply the coefficients together, meaning the numbers out in front, and we're going to keep the variables. So in the case of number 1, 7a times 4 is just going to give us 28a. Hopefully you had that. On number 2, 4k times 3k, this is more like what we did in the exponents unit. And the key here is we're still going to multiply the coefficients, but we have to remind ourselves now that we have the variables, we have to do something else. And actually, not just number 2, but number 3, this applies as well. What we're going to do is we're going to multiply those coefficients, same way that we did in example 1. But from our exponents unit, we know that we're supposed to add the exponents on the like terms in this case. So what that means is in the case of number 2, if we have 4k times 3k, we want to remember those are exponents of 1, and we're going to multiply the 4 and the 3 to get 12, but we're also going to add the exponents to get k squared. So 12k squared is our answer for number 2. We're going to do the same thing in number 3, and the first thing I would suggest is writing in our coefficient there in the second parentheses is -1. The exponent on the end in the first parentheses is also 1. Those are values that we don't have to write, but we want to remind ourselves that they are there. So now when we multiply the coefficients, -3 times -1 is going to give us 3. And then we're going to add the exponents. So we're going to get m to the 9th and n to the 3rd, because we're going to take the 4 plus the 5 for the m to get 9. We're going to add the 1 and the 2 to get 3 for the n. So 3, m to the 9th, n to the 3rd is our final answer there. So really, we've already done this kind of multiplication before. And actually, we've also looked at multiplying other types of polynomials. When we took a monomial times a polynomial, it's just we referred to it as distributing and the distributive property. So in these cases, we're going to take the number outside and multiply both things inside the parentheses, or all of the things inside the parentheses. So in the first case, number 4 here, remember, if I were to multiply 4 times x plus 5, that's really like 4 times 1x plus 5, we multiply both the 1x times the 4 and the 5 times the 4. So that means we're going to end up with 4x plus 20. Now I can't combine those. They're not like terms because the 4 has an x with it, 20 does not. So 4x plus 20 is our final answer. And in number 5, now we have -2 times 2a squared minus 4a plus 6. We're going to do the same thing. We're going to distribute the -2 through the parentheses. And in this case, there's no variable outside, so we're really just going to change the coefficients. We're going to get -4a squared. We're going to get positive 8a. And we're going to get -12 or -12. And again, not like terms, can't combine them. We leave it the way it is. That was part of what we did before with multiplying monomials by polynomials. We even included some where we had variables on the outside. We're going to be reminded of this a little bit more in this lesson. So here in number 6, I basically have the same problem that I had in number 5, except I've added an a out in front as a coefficient. So not only am I going to change the coefficients the way I did in the previous example, but I'm also going to be adding 1 to each of the variables for their exponents. So that means when I take the negative 2a and distribute it, my first term should still have a coefficient of negative 4, but now it's going to be a cubed, or a to the third. Then we'll get plus 8a to the second, or 8a squared, and then we'll get minus 12a. Again, no like terms because they're all different exponents. I cannot combine those variables together. Go ahead and try number 7 on your own. Hit pause, and then when you're done, start up again. Okay, so here we go. We're going to distribute the 5x squared to the 10x and the 7. 5x squared times 10x, we get 50x to the third. And then we're going to take the 5x squared times the 7, and we should get plus 35x squared. Can't combine those variables. We're going to leave it the way it is. That's our final answer. So that's the extent of the multiplication that we've done before with polynomials. What we're really interested in is, what if I have something other than a single term, a monomial, times a larger polynomial? Let's say we had a binomial times another binomial. This is going to be the main point of this lesson and the biggest thing that is new to us. And what we're going to see is that when we multiply two binomials, we use this process that we call FOIL. And really, it's a way of double distributing, because what we're going to end up doing is we're going to have to take both of the terms in the first set of parentheses and multiply them by both terms in the second set of parentheses. So here in number 8, we have n plus 5 times n plus 7. And FOIL is actually an acronym, because FOIL stands for the process by which we do our multiplications. So we're going to walk through here. The F in FOIL stands for first, meaning we're going to multiply the first term in each set of parentheses. In this case, our first multiplication is n times n. That would be n squared. Next, we go to the O. The O stands for outside or outer terms. If I think about those 4 terms, the n plus 5 and the n plus 7, the first n and the 7 are on the outside of the group of 4. So that's going to be our outside multiplication, and that's going to give us positive 7n. Oops, I erased too much there. So let's see. N squared plus 7n is what we have so far. Next, we move to the I in FOIL. And if O was outside, I is going to represent the inside multiplication that we're going to do. And in this case, the inside terms are the 2 terms in the middle of the group of 4, the 5 and the n. We multiply those, we get plus 5n. Next, we come to L. This is our last letter in the acronym, and actually, the L represents last, meaning I'm going to multiply the last term in each set of parentheses. In this case, the 5 times 7, which gives us plus 35. At this point, what we can see is we basically did 4 multiplications. We did the n times n, the n times 7, the 5 times n, and the 5 times 7. That's our double distributive property. We multiplied the first term in the first set of parentheses by both terms in the second set, and the second term in the first set of parentheses by both terms in the second set. So we have our 4 multiplications. You do want to be careful when you multiply here, though, because if I look at what I have, n squared plus 7n plus 5n plus 35, that's not quite my final answer. I would want to go a step further and notice that the outside multiplication and the inside multiplication are actually like terms, 7n plus 5n. So what I'm going to do is I'm going to combine those, and I'm going to rewrite my answer in standard form, largest exponent first. So n squared plus 12n when I combine those two multiplications, plus 35. There's my final answer, n squared plus 12n plus 35. And FOIL is probably the second most popular, or maybe even the first most popular thing people think of when they say Algebra 1. We talked earlier in the year about slope and y equals mx plus b being something that people remember from Algebra 1. FOIL is also up there as one of the main ideas that we get into that you're going to keep coming back to and revisiting in other math classes down the road. Let's look at some other examples of FOIL. In that first example, all my terms were positive, so I didn't have to worry about too much. But in the case of number 9, number 10, number 11 here, we have some things that we want to watch out for. So let's first look at number 9 together. Going to go through the steps. First multiplication, a times a, that's a squared. My outside multiplication, a times 9, that's going to be plus 9a. But now when I do the inside and the last multiplications, I have to watch because the second term in my first set of parentheses is minus 4 or negative 4. So that means for the inside multiplication, I'm going to do negative 4 times a, which is minus 4a. I'm going to do the same thing with the last multiplication. I'm going to end up taking negative 4 times 9, which is minus 36. That's important because I want to make sure I include those signs with the terms. I'm not always going to end up with all plus signs. In this case, when I combine my like terms, I have a positive 9a and a negative 4a. So I want to be careful when I combine those. I'm still going to have a squared as my first term, but then it's going to become plus 5a because we do 9 minus 4 basically, and then we have the minus 36. So a squared plus 5a minus 36 is our final answer. Go ahead right now, try number 10, try number 11, and again, be careful with your signs and pay close attention to those because they're going to affect the final terms in your answer. So hit pause, try 10 and 11. All right, let's look at number 10. So on number 10, we have k minus 4 times k minus 1. First multiplication, still k times k, that's k squared. My outside in this case is going to be k times negative 1. That's going to become minus k, or negative k. Then the inside is negative 4 times k. That's going to give me negative 4k, or minus 4k. And my last multiplication is going to end up being, in this case, the negative 4 times the negative 1. Let's get a different color here. So we're going to take negative 4 times negative 1 for the last multiplication, which is going to become a positive 4. So now, again, my outside and inside multiplications, oops, wrong color again. Here we go. Are negative k and negative 4k. Final answer. K squared is the first term. Then it's going to be minus 5k and plus 4. So hopefully you had those signs correct. In number 11, something interesting happens because in all of our answers so far, what we've seen is we're starting with 4 terms, basically, 2 groups of 2. And we multiply them, we end up with 3 terms in our final answer because we get some like terms that combine. Well, in number 11, it starts off basically the same way. First multiplication, 2h times 2h, 4h squared. Our outside multiplication is going to be the 2h times the minus 3, or negative 3. And that's going to be minus 6h, or negative 6h. But my inside multiplication is now positive 3 times 2h. That's plus 6h. And then my last multiplication is going to be 3 times negative 3. And that's going to give us negative 9, or minus 9. And the key here is when we look at our middle terms, the negative 6h plus the 6h, they're like terms, but they're exactly the same, but they're opposites, which means they cancel out. So we're left with just the 4h squared minus 9. That means that there will be times when we multiply polynomials together, or multiply 2 binomials specifically, we're not going to necessarily end up with 3 terms every single time. Number 11 shows us if I have the exact same terms but different signs in the parentheses, the outside and the inside multiplications could cancel out and leave us with just 2 terms in our final answer. All right, we got a couple examples left here. Number 12, we have 3y minus 7 squared. I want you to be careful here and remember that we do not distribute an exponent through a quantity like this. I'm not going to take 3y squared and 7 squared. Instead, what we're going to do is we're going to rewrite the expression, and we're specifically going to rewrite it in expanded form, which means I'm going to take 3y minus 7 squared and think about if it's squared, that means I actually have the same quantity twice. And I'm going to distribute, basically double distribute, or FOIL in this case. I'm not going to just square both terms. I have to rewrite it, and then I have to FOIL it. So go ahead and FOIL number 12 on your own. Hit pause. When you're ready, come back and check your answer. All right, so we're going to FOIL. We're going to take 3y times 3y. That will give us 9y squared. We're going to take the outside, 3y times negative 7. That's negative 21y. We're going to take the inside, which is negative 7 times 3y as well, another negative 21y. Our last multiplication will be negative 7 times negative 7, which is positive 49. And in this case, we get the exact same middle 2 terms, not opposites. In this case, they both have the same sign as well. So we're going to combine those. They don't cancel out. Instead, they basically double. We're going to get 9y squared, but then minus 42y, and then plus 49 as our final answer. All right, we have one last example here, number 13, where we have r plus 1 times 2r squared minus 3r plus 4. And what you're going to do is basically the same idea as FOIL, except I now have a binomial times a trinomial, which means for the first term in the first set of parentheses, the r, I have 3 multiplications to make. I have to distribute it to the 2r squared, the negative 3r, and the positive 4. So check and see, what do you think you're going to get when you distribute the r? If you distribute the r, you should get 2r cubed minus 3r squared, and then plus 4r. Since I had to distribute the r to all 3 of those terms, I'm also going to need to distribute the 1 to all 3 of those terms. So I'm going to take the 1 times 2r squared, the 1 times negative 3r, and the 1 times 4. That doesn't really change anything. I really just rewrite those terms because I multiplied by 1. And lastly, we're going to now combine our like terms from our multiplications. In this case, you can see we basically did 6 different multiplications. We want to rewrite our answer starting with the largest exponent, because we're in standard form, down to the smallest. So in this case, the 2r cubed is our largest term or largest degree, so we can't do anything to combine that with anything else. We can combine the r squareds. Negative 3r squared plus 2r squared is minus r squared. We can do the same thing with the r's. Positive 4r and minus 3r is plus r. And the plus 4 cannot be combined with anything. So there's our final answer. 2r cubed minus r squared plus r plus 4. Just a reminder, you've heard me say this multiple times throughout the video. When we were multiplying these and writing out our answer, we want to make sure that we always put our answer into standard form, meaning always start with the largest exponent down to the smallest exponent. So we want to make sure we do that. And we talked a little bit about this last week. Part of the reason we use standard form is to make it easy for us to compare our answers to other people's answers. It tells us information about the polynomial. And in this case, it's good habit to always write our answers in that form. I hope you guys found this video to be pretty straightforward. If for some reason you have questions or you need clarification on anything, don't be afraid to reach out to me. We'll be meeting on Zoom on Wednesday again at our normal time, so don't forget to check in on that. You'll see in the weekly agenda for this week, there are some IXL topics you're going to practice on multiplying polynomials, as well as a graded assignment, which is going to be a worksheet that you're either going to need to download and do in Kami, or you can print it and write on it, or you can just copy the problems onto scratch paper. And what you're going to do is you're going to show all your work. When it's done, you're going to take a picture of it or scan it, and you're going to submit that as an assignment on Schoology. If you have questions on that, please let me know. As with last week, these things are going to be due by Friday at noon. Some of you still haven't done the work from last week. You want to make sure that you finish those IXL topics from last week by the end of this week as well. I hope you guys are all well, and if you have any questions, let me know. Otherwise, I'll talk to you later, and good luck.